So first thing we're going to do is do this warm up. So go ahead and do this and then come back to me when y'all are done. Okay, so the method we're using here is the quarter method. So we're going to take the 45 and divide it by 4. And when we do that, we get 11.25. And so that's going to be, and all we're concerned about is that 25 cents right there, right? So how many quarters is that? That's 1 quarter. So this is I to the first, which is, yes, I. So the answer was B. With the multiplication, now again, there's a couple ways you can do this, but most of y'all are going to feel more comfortable doing it by putting these side by side, right? So 3x minus 2 times 3x minus 2. Then you can use whatever method you want, FOIL, box, x, t, whatever. So I'm going to use the box method, and I'm going to do it like this. Oh, and over here, I'm going to put, again, my 3x and my minus 2. I'm going to close my box over here, right? Okay. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. 3x times negative 2 is negative 6x again. And negative 2 times negative 2 is negative 4. Okay. So you should always notice that if you're using the box method and you do them in descending order, in other words, do the x to the first and then the constant, that your like terms are going to be in the diagonal. So now we're just combining the like terms. Oops, I forgot the squared, y'all. 9x squared, x times x is x squared. So this is going to be 9x squared minus 12x plus 4. So that was, whoops, not that one. Wow, I'm having issues today, y'all. Can't even circle the correct answer. It was that one, okay? All right. So now we're going to talk about yesterday's ticket out the door. So this is yesterday's ticket out the door. So once again, we're going to factor that square root of negative 20. I'm going to leave this negative 4 out here. And then I'm going to do the square root of negative 1. And I know that 4 times 20 is, that's got a perfect square in it, right? I mean, 4 times 5, sorry. So again, if you don't know this, then factor the 20. Do 2, 10, 2, 5. Notice that 2 times 2 right there, that's 4, right? So those are your numbers that you're putting underneath your radical, the square root of 4 and the square root of 5, okay? So here we go. This was negative 4. Square root of negative 1 is I. Square root of 4 is 2. And the square root of 5. So we're going to combine the negative 4 and the 2. So that's going to be negative 8. And then I, square root of 5. So today we're going to be going over adding and subtracting with complex numbers. So these are the objectives today. I can identify and solve both the real and imaginary parts of a complex number, and I can use the relation I squared equals negative 1 when necessary to add and subtract complex numbers, okay? So yes, maybe it's going to go to the next slide. There we go. Wait, there, yeah, sorry. So in y'all's notes, it says a complex number is a number that can be written in the form a plus bi, that's your first blank, y'all, a plus bi, where a and b are real numbers, that's your second blank. And yes, I know that's a lot to write in that little blank. And where I is equal to the square root of negative 1. So a complex number is a number that can be written in the form of a plus bi, where a and b are real numbers, and I is the square root of negative 1. So the set of real numbers is a subset of the set of complex numbers, C. So every complex number has a real part A and an imaginary part B. So that's what I mean here, okay? So the real part and the imaginary part. Y'all see that? The real part is the A. The imaginary part is the B because it's attached to the I. So two complex numbers, so y'all might want to write that down on your paper. The A plus BI is the real part. So A is the real part and BI is the imaginary part, okay? So two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. So we're going to talk about what that means in just a minute, okay? So first of all, let's talk about some numbers. So real numbers are like negative 1/2, 1.730 pi, negative 9.6 repeating, and the square root of 2. Those are all real numbers, right? Well, imaginary numbers simply mean they have I attached to them. Or in the case of the square root of 7, negative 7, isn't this the square root of negative 1 times the square root of 7? So this is really what? The square root of 7 times I, right? Okay, so now let's talk about these. So this is what I want y'all to do. For the real part, let's circle them, and for the imaginary part, let's square them, okay? So real part of this number is the 3. The imaginary part is the 7i. The real part, again, the 3. The imaginary part, the 2/3 I. The real part here, 4. The imaginary part, negative I. And we got to keep that negative attached to it, okay? All right, now, so we're going to equate two complex numbers. So we're going to find the values of x and y that make the equation true. So this says example 1a, so we got 3x plus 12i equals 9 plus 4yi. So notice that we have some real numbers on the left and the right, and some imaginary numbers on the left and the right. So what we want to do is we want to find all the real numbers and set them equal to each other. And we want to find all the imaginary parts and set them equal to each other. So notice this is real and this is real, right? So we're going to do 3x equals 9. And then also the 12i is imaginary, right? And then we got the minus 4yi. Minus 4yi. So this is equal to minus 4yi. So now we're going to use the same properties we've always used to solve these, right? So on the left, we're just going to divide both sides by 3. So x is equal to 9 divided by 3 is 3, right? Now on the right, we got to get y by itself. So we're trying to get the x by itself on the left, and on the right, we're trying to get the y by itself. So what we want to do is divide by everything that's not y. So we're going to do minus 4i, right? We're going to divide by all that, okay? And over here, we're going to divide by negative 4i. Now, notice over here, everything now is gone except for that y, right? Because we got rid of it. So we're left with y over there. And notice what also happens with our i's here. They cancel each other out, right? So positive 12 divided by negative 4 is equal to what, y'all? Yes, it's equal to negative 3. Now, remember, you can always check these. So you can plug these back up in there by doing 3 times 3 plus 12i is equal to 9 minus 4 times negative 3i, right? So now this is 9 plus 12i equals 9 what? Negative times a negative is a positive. Remember that. 4 times 3 is 12, so that's going to be plus 12i. So you can even check it, right? By plugging your values back in, okay? So here's the next one. Again, we're going to put the real parts with the real parts and the imaginary parts with the imaginary parts, okay? So that's real, and that's real. Y'all see that? So we got real parts over here. So we're going to do 8x minus 7 equals 9. I'm going to put me a little wall here, and we're going to do an imaginary over here. Got it? Now it says solve for x and y over there on the right, but I'm going to do it over here. No big, okay? So again, we got our imaginary part, 24yi, and that's equal to negative 12i, okay? So once again, what are we doing first over here on the left? Aren't we going to add 7 to both sides? So that's going to be 8x equals 16. Divide both sides by 8. So x is equal to 2. Got it? Now over here on the right, again, we're going to try to get the y by itself. So we're going to divide by 24i, and we're going to divide this by 24i, okay? So once again, notice that those i's are going to cancel each other out. So we got negative 12 divided by 24. So isn't that going to be negative 1/2, y'all? And that's equal to what? Remember, this cancels out that, and that. And what are we left with? Y. again, you can plug it back up in there just to double check and make sure that you got the same numbers again, okay? All right, example C, again, I'm going to do real, that's -8, and then we've got 5x, right? So -8 equals 5x, I'm going to divide both sides by 5, so x is equal to -8/5, right? Then we got our imaginary. So here we go again. We got the 6yi, right? And that's equal to, notice we've got -I square root of 6. So remember, once again, we're trying to get that y by itself. So we are going to divide by 6i, and we're going to divide this by 6i. And oh, but yeah. So now let's cross out what is gone. That's gone, that's gone, that's gone, that's gone. So we're left with the y over there. And we cross out our i's, right? So this is going to end up being negative square root of 6 over 6. Okay, now I'd like you guys to do these two and then come back to me when you're done. So I'm going to go ahead and do real to real. 2x equals -8 divided by 2. X equals -4. Then I'm going to do imaginary. So that's going to be -6i equals 12y. Again, trying to get y by itself, so we're going to divide both sides by 12i and 12i. So once again, let's mark out what we got rid of, right? So that's just y over there. And over here, we're getting rid of our i's, and -6 over 12 is equal to, again, -1/2. And remember, you can always plug these back in to check them, okay? So here we go again, real, real, real. How do I know those are real, y'all? Yes, because they do not have I attached to them. So we got 4x plus 13 equals 5. We're going to subtract 13 from both sides. So this is going to be 4x equals -8. Divide by 4. And so we get x equals -2. Now we're going to do our imaginary parts again. So that's imaginary, 7yi, and that's imaginary, equals -21i. So again, remember, we're trying to get that y by itself, so we're going to divide by everything else. 7i, that's a 21, y'all, and 7i. So again, just to clarify, we're getting rid of everything but the y, right? So we got y over here. And then we're getting rid of that I cancels out I, right? How many times does 7 go into -21? You got it, -3. Okay? All right, so the next thing we're going to do is we're going to talk about how to add together, take the sum of two complex numbers. So when we do that, we notice we're going to add the real part to the real part. That's why we got a plus c here. And that's in your notes, right? And then we're going to add to it the imaginary parts again. So like terms, y'all see that? So what we're going to do here is we're going to do, when we do this, we're going to do a plus c, just like it's up there, right? And then we're going to add to that r, b plus d, okay? Now the difference, again, is the same thing. So, or similar, I should say, real to real. So we've got our a minus c, because now we have a minus sign. Okay, and when we're doing our imaginary part, same thing. So we're doing bi minus di. So it's really what? B minus d, okay? With the I on the outside, okay? So these are really like terms. Y'all see that? This one had the I on the outside right there. But either way works. Okay, so then it says complex numbers also have additive inverses. So the additive inverse of a plus bi is minus a plus bi, which would be minus a minus bi. Okay, which basically just means you change the sign of everything. All right, so now we're going to add. So to do this, everybody listen, we're going to take real part to real part and imaginary part to imaginary part. So there's our real parts, right? So I'm going to do 4. And when I add a negative, I'm just subtracting it, right? And then I'm going to add to that my imaginary parts. So there's my imaginary parts, okay? There and there. So I'm going to add to it 2i. And again, when I add a negative, I'm just going to subtract it. So when I do this, I'm going to get 4 minus 6 is minus 2, right? And then I'm subtracting 7i from 2i, so that's going to be minus 5i, isn't it? So that's my answer, okay? So all you're really doing here is combining like terms, guys. That's really all you're doing, okay? So here again, 5, and this time we got a minus. Y'all see that? So we're going to do 5 minus a minus 2. And I like to put this stuff in parentheses so I can keep it together. Okay? And then I'm going to do the imaginary parts. And remember, we're subtracting this time. So we're going to do minus 2i minus a minus 3i. And I talked to y'all about this already. I like to change the sign, change what's behind. You don't have to do that, but you can. And sometimes when you do that, it'll help prevent an error, right? So here I'm going to change the sign, change what's behind, change the sign, change what's behind. So 5 plus 2, that's 7, right? And then we got negative 2i plus 3i, which is going to be just plus I. So that's 7 plus I. Okay? Last one. Now this one has 3 different terms. Y'all notice that? So I've got real 12 plus real 7 minus 3. Okay? Now I got my imaginary parts. So I got my 5i plus a negative 9i. Remember, if I'm adding a negative, I'm just subtracting. Now we got minus a minus. Y'all got that? So I'm going to put that because I don't want to forget that. Okay? And that's a common error. Okay? So here we go again. So this time, the only place I have a minus next to a minus over here, so I'm going to put plus plus. So 12 plus 7 is 19, minus 3 is 16, right? We got 5 minus 9, that's minus 4, plus 1, so that's going to be plus 3. No, wait, nope, I made a mistake. See, you might want to combine these as you're going. Y'all got me? So if that helps you, so let's just do that. So this is going to be minus 4i, right? Plus I, which would be what? Yep, it's going to be minus 3i. See, teachers make mistakes too, y'all. Minus 3i. So that's the answer to that one. Okay? All right, so I'd like you guys to do the U-tries and come back to me when you're done. So let's just go on to these, okay? So go ahead and do these, and when you're done, come back to me. All right, so again, real, real. 1 minus 1 plus negative 3i plus 3i. Wow, that's going to be 0 plus 0, y'all, which is what? Yep, 0. Okay, again, real part. There is no other real part. Y'all see that? And so then we're going to go plus 5i. Again, when we're adding a negative, we're subtracting it, okay? That's going to be negative 3i minus I. Sorry, not 3i, negative 3. Let me erase that. Sorry, y'all. Negative 3 minus I, right? Okay, down here, we've got a 2i minus a 5i, right? And then we're adding the 3. Yes, you could have just done that imaginary part because there was no real part to the first one, right? So here we go again. So this would be minus 3i plus 3. Now remember, we're always going to, when we do these, standard form for these problems are you're going to put the real part first. This is going to be 3 minus 3i if you write it in standard form. Okay? Which would have helped if I'd put the real part first. So there we go. So now here, real part, 4 minus 4, right? Imaginary part, 7i minus a minus 7i. Again, just always remember when you have two negatives next to each other, y'all, it's going to end up being a positive, right? So 4 minus 4 is 0. This is going to be 14i, right? So the answer is 14i.